So when we have a system of equations, if we have two equations, which mostly that's what we're going to be working with here, there are three possibilities. Maybe one linear equation is a line like this, and the other one is something like this. And those two lines intersect at a point. Not necessarily at right angles, but they just intersect. That point is the point that satisfies both equations, right? So we get an ordered pair solution. It's supposed to say x sub 1, y sub 1, and that would be the solution. 1 point is the solution. And so sometimes we're going to be solving a system of equations, and that's going to be the case where there's one solution and it's an ordered pair and one x and y that makes the system true. Now we could also have two lines, maybe a line like this, and maybe the next line is parallel. So when we have parallel lines, because that can happen, just means the slopes were the same. If you have parallel lines, there's no solution here. Or you can put the empty set. Okay. And then this last case is kind of different. But sometimes we have a line, and then we graph the equation of the line, and then the second equation is actually the same line. And they coincide, okay? So this is when you don't really have two different lines, but rather they're the same line. They might look different, but they're the same line. And this has many solutions, or an infinite number of solutions. And the solutions are all the points on the line. So all points on the line, because you really only have one line. It's not two different lines that they gave you. Anyway, those are the cases that we have. So it says solve this system by graphing. So one way to solve a system of equations is by graphing. And so we're going to show you how that works. Showing this first one, maybe I want to, let's turn it into slope-intercept form. So if I have x minus 3y equals negative 3, and I were to take the x to the other side, I'd have negative 3y equals negative x minus 3. And then if I were to divide everything by negative 3, so we're putting it in slope-intercept form. It's a good time to review that. We get y equals 1/3 x plus 1. Now that line I can graph. So I put the y, it's got a slope of 1/3 and a y-intercept at 0, 1. 0, 1, and then I'm going to count it up 1 and over 3, up 1 and over 3, and I can graph that line. That line then is represented by, or that equation is represented by that line. Those are all the ordered pairs that make that equation true. Now I'm going to switch colors. And so I'm going to do this equation. I have to graph it. And maybe I'll just use the table of values. I can think of some ordered pairs that add to be 5, 2 and 3, 1 and 4, 0 and 5. I'm just making up, I'm just making up some numbers that add up to be 5. It's okay, it's a way to graph. Show 2, 3, there's an ordered pair, 1, 4, right there, and 0, 5 right there. Now you might say, well, why didn't you do it the way you did the last one? You could get it in slope-intercept form, use the y-intercept and the slope. You're going to get the same line. And then that's where that equation, all the ordered pairs on the green line, make that equation true. Now the big question is, what's the solution to the system? What ordered pairs make both equations true? Well, it's the ordered pair where they cross. I tried to do it in a different color. It didn't work. It's that ordered pair where they cross. It looks like it's 3, 2. Now, I'm going to say that's the solution, and I'm just reading it off the graph. Sometimes it's hard to read them off the graph. You just do your best when you're solving by graphing, you know. So that's the tricky thing about this method. But we're going to learn some other methods. But anyway, there, we solved it. Solved by graphing. Okay, so here's another example. Maybe I'll stick with what I had before. So if I take the x to the other side, I have y equals x plus 1. Then I don't have to worry about a negative x. Now I can graph using the slope, which is 1 or 1 over 1. And the y-intercept, that y-intercept is 0, 1 again. It seems like that keeps happening. The y-intercept isn't always 0, 1, but okay. And then I'm doing the slope, up 1 over 1, up 1 over 1, rise over run. And so I get a line like that. It's supposed to be a straight line. Anyway, that equation then matches to that line that I just drew. Now we're going to take the other one. Now, I was trying to kind of refresh your mind on the different methods of graphing. So I have 2x plus y equals 10. And I'm going to use the intercept method. So I'm going to make a little table of values, x and y, and I'm going to plug in 0 for x. That gives me 10 for y. And I'm going to plug in 0 for y, and that's going to give me 5 for x. Now you can go through that math and do that, so that's not a problem, hopefully. But I didn't write it all out, but that's what they turn out to be. So 0, 10 is going to be way up here. And then 5, 0, 1, 2, 3, 4, 5, 0. Okay, so, you know, maybe I want to pick something in the middle, you know, a third point. I guess I could use 2.5 for x. We don't usually pick a fraction, but we can. Now what happens, I didn't do this for the other 2 points, but I'm plugging in 2.5 for x, and then I'm going to calculate what y is. You can do it for the other points too, but, you know, if you subtract 5, then you say, well, I don't want to pick 2.5. You don't have to. You could pick another number. I was trying to get something that was going to work out, you know, kind of in the middle. But you could have picked 3 or 1 or some other number. And then you just kind of have to guess, you know, if it doesn't come out to be an integer, you're going to have to approximate how to graph it, just like I'm going to have to do with the 2.5. So 2.5 and 1, 2, 3, 4, 5. And it's about there. And that's kind of what we were expecting. So this is going to graph like this. A ruler helps, graph paper helps with these. It looks, where do they intersect? It looks like it's about here. Now I might be off a little bit. I don't know that that's the exact answer, but I'm going to say that's pretty close. 1, 2, 3. And I have to find the ordered pair that I have in blue there. Looks like 3, 4 is what I'm getting. So yeah, that actually works if I plug them in and try them into the equation. But with the graphing method, we just do the best we can. So if you had, like on your test, 3.1, 4, I'd be okay with that. Or if you had 2.9, you know, and it's really hard to approximate those on the little graph paper. But we just do our best with the graphing method.